Okay, if you don't have the setup, just go to the link and put it to download. So today we will discuss regarding the overview of Python and how to install the Python. Then we will go with Jupyter Lab. How many of you guys using Jupyter Lab? For this one, we will use Jupyter Lab. If you are familiar with the Spider, we can go with the Spider as well. So for this training, I will use Jupyter Lab, and then we will go with syntax, and then we will go with some libraries. So for the overview of Python, what is Python? I need answers. What is Python? Since you know, you can like answer at the end. So anyone else need to attempt what's Python? So it's a programming language. Someone is saying a programming language. Anything else? Anyone? Just answer. I'm not going to do anything. Just like answer. So you can answer now. Okay. In simply, Python is an interpreter object-oriented high-level programming language, as he said. And then for this one, if you know, some guys are familiar, I know they are familiar with Ruby, Perl, PHP, Matplotlib, or if you are into like web development or something, you know about these libraries. But some guys will know Matplotlib and R as well. And then C++, C, Java, and Fortran. The guys who are focusing on math, like math, they typically know Fortran. Most of the guys who are focusing on math, they know about Fortran. So this is the basic structure. It's like simply we can say it's a high-level programming language. And then why we are using Python? So Python is open source and is free to use. And also there are some additional things like it's simply the simplicity of the usage, because in Python we don't need to write that many of code. If you are familiar with other programming language, you know, like you have to type multiple lines to like do a task. But in Python, you can like only write 1 or 2 lines and like do the same thing very easily. That's why we are using Python. And then it's very powerful, because if you know, we can use this one across multiple devices, like any like if you go with the laptops, computer, like mobile phones, anything it supports. And then the battery is included. That means we have huge amount of libraries, like lot of libraries. Last time, some of the guys who are focusing on meteorology, they were asking about me why you are not conducting NCL, because NCL is now outdated. How many of guys are in here who are doing meteorology? So they know what I'm saying. Last time we did the NCL training, but the problem is now NCL is outdated. They are now not providing NCL like the last time that we used. Now NCL is also converted into the Python. Now they like issue the Python library. We can use the Python library and use the Python to do the same thing. So we will discuss about some libraries as well at the end. And this one is in which areas we use Python. As you know, we use Python in a lot of areas, not only in programming. We are using in like for, especially for us, we are using for the analytical purposes. And sometimes we are using this one to display like some images or plot some images, especially plotting the graphs for the research papers and analyzing. Sometimes we are using this one for machine learning purposes as well. So this one is using in lot of, like Python is used in lot of sectors, but here we are using for the scientific purpose. So if we call with the scientific Python stack, we have different libraries and modules that we have to go through. So here is the typical Python stack. So Python is the language, like the base, and then we have core libraries like NumPy, MATLAB, Matplotlib, and Xarray. Then we have this Jupyter notebook and Jupyter. There's like a lot of things over there in Jupyter server and everything. And then we have Pandas, SciPy. How many of you are familiar with these libraries? Okay, Josh can answer. What libraries you have used? For what kind of task you will use it? Typically, we are using this one, the Matplotlib for plotting functions. If we need to plot something, we will use that thing. Anyone else? What about NumPy? And then we have specialized functions like Dask. Dask is here, we are going for the parallel processing. If your PC is like low end, we can use parallel processing to do the task. And then in the domain specified, we have this one. How many of you know about this one, the MetPy library? The guys who are doing meteorology, they should know about this one, this library. They typically know about this one, the MetPy. It's like the meteorological package for displaying and everything for the regarding the Python. So typically in this one, we will try to discuss about this little bit, but we will discuss about NumPy because we need to have this one, and then Matplotlib, and then Xarray. These are the common libraries that we are using, and then Pandas. How many of you are using Pandas? But if I say the code import Pandas PD, you know at the beginning you are typing this one. Even if you are extracting the code for somewhere, you are extracting this one. Why we are using Pandas? Why we use Panda? If we need to deal with tabular data, we have to use Panda. So we will discuss about these libraries later onward, and SciPy as well. I will discuss about this one as well, this library as well. And there are some other libraries that not mentioned in here. So if we call about like useful packages, we have more than 200,000, more than 200,000 packages. Right now, I think the number is increased. This one is like last year presentation I used this year as well. So it's typically like more than this amount. So we will use pip or conda for installing of these things. And then this one, you need to have to know about this one. So we are using Anaconda because Anaconda is a package manager. So we can like manage what are the libraries we need. We can like import those libraries and do the task over there. So when you are choosing the right packages, you need to follow like 3 rules for your task. You don't need to import all the libraries that you know. For your specific task, if you know the libraries that you need to import, first you need to install the libraries into your environment and then you can use them. So for that thing, you need to have knowledge about the packages. So for these things, we need to check whether this package has continuous support or not. So if that package doesn't have support, then in the long run, you cannot like use that package. They will like say it's like obsolete or like outdated. And after 5 or like several years, that package will like not be over there in the we call like Anaconda or conda-forge libraries. Then the community support is the other thing. You have to go into that library, like the package file over there. They should have like their own website, so you can go over there and check for the community support. So just imagine if you have Pandas, you can go to the Pandas website. Over there, they have like community group. So if you have a problem with Pandas, you can like take a screenshot of that thing, and even you can like get the error and copy and paste it over there, and in the community someone will answer for your question. So you can get the support for that thing. So you have to check for that community support as well when you are checking with the packages. And then efficiency for coding. Sometimes you will see there are several packages that you can use to do the same task, but you need to choose the right package. Just imagine if you need to write multiple codes, you don't need to go with that package. So if there's another package, you just need to import one library and then you can call that thing and it will do the calculation automatically because the function and everything is pre-built in that library. So you can choose that library and install in your environment. So these are the 3 rules you have to follow when you are like into the program. So next thing, for the Python, we are using this one for general utilities and data access. There are some libraries for the data access, and then there are libraries for general utilities, and then there are some libraries for visualization. As we discussed, for the visualization, we can use what we call Matplotlib, and then we will use Cartopy. If you are going with the geographic plotting, then you need to know about Cartopy as well. So those 2 are the libraries that we will use for the visualization, and then meteorology focus libraries, as we discussed, MetPy. This is a meteorology focus library. Then there are some libraries related to oceanography, then climate, then data reduction and spatial grids, and then modeling. We have like lot of libraries that we can select. And then for the general utilities, these are the libraries that we will need. For GeoCAT comps, this one you can go to this website and see. Last time I say, if you need the NCL, last time we used NCL as a different like language in car command language, but now they converted into Python. If you go into the website, I think in the website they mention about this. Let me try to open this one. So this is their website, as I say last time. So here we have the installation instruction. If you know about the API, that thing is also there, and there are some documentation, release notes, and then computer like contributors guide, and we have support. So if you have any issues with this library that we are going to use, we can go to the support section, and over there see if we have a bug or something, we can report to them, and then submitting feature request. If we need any new features to be added into this library, we can ask them to add this one. So they will add it like in the newer version. And then there are some lot of things over there. Typically they will have a GitHub support as well. Sometimes some libraries have GitHub support as well. So you can go over there and like check for these things. And even we have usage examples. So what kind of things we can do for this one? See, so typically in your research papers you will see this kind of graphs. So if you need to draw some like this kind of graph, you can simply click here, and like then they will provide the sample code. But now the problem is how to modify this thing. So you have the code, but you need to modify, because you cannot use the same data file. Here we are reading the NetCDF file, and then we are calculating 6 hours surface temperature data. And then we are plotting it using, typically I think we are using Matplotlib. Yeah, here we are importing Matplotlib and PyPlot. This is for plotting. So every library you have this kind of website. So the next one is PyFerret. We are using PyFerret for oceanographic data when we are using like for modeling or something. Let me open that website and show it to you guys as well. So for this, all the libraries we have their own like dedicated library. So if you see the website, you know this one is coming from NOAA. So the guys who are focusing on climate and these things, they know what NOAA is. So it's coming from NOAA. So it's taking some time. I think I'm not turning on the VPN. That's why it's taking some time. If you turn on the VPN, it will load much faster. So next one is XCAT. These are like some typical libraries that we will use. And for the data access, you know about this one. How many of you guys have heard about like CMIP6? So if you are into climate and these like climate sciences, we will use CMIP6, different like CMIP6 models. So we don't need to go into the like their own website and download the data from there. So if we use this library, we can download the data directly through the coding. We don't need to go to the website and start downloading the data. We can use this one. So over there, if we go into the website, they will show their documentation as well. So quick installation guide, how to install this one is over there, how to use this one, everything is over there. So the functions that they are using, even if you need how to download the data, they will show how we can download the data. First we need to import the library, and then we have to specify the current default directory or current directory and where we are going to download, and then likewise like this we can start downloading data without going to the website. So this is much more advanced. Last time, just imagine if you need to download 1 TB or like 500 GB of data, it will take like 1 or 3 days to download. But what will happen if all of a sudden download cancel? Last time we faced the same situation, like we had to download 1 TB data and we put it to download, and like after 2 days, it like cancelled the request. So we have to download it from the beginning. Then we go with this library. So we can like continue from the where the download is stopped. So that's the advantage of this one. Typically these NetCDF files are like huge. It's not like small. So we can use these kind of libraries to download the data. And the other one is ECMWF. If you go into the ECMWF, this one is European Commission website. So typically we are using ERA5. If we are using ERA5 or something, we can use this library to download the ERA5 data. And then Siphon. Siphon is also an advanced library which we are using in Unidata, because Unidata is also from UCAR. As we know, UCAR is the one who developed NCA as well. And then for the visualization, we have these libraries. Since we are focusing on meteorology, we need to know about these libraries. First one is Cartopy. If we are going with geographic projection or mapping or anything, we need to know about Cartopy, because if you go into the Cartopy library, you can see we are using Cartopy for this one. Like if you go into the gallery, you see all the map projections and everything is there. So that's why we are using Cartopy. If we need to plot a spatial plot or something, then we have to use Cartopy library. That's why we need to know about this library as well. Over there also they have their own API system and everything over there. If you go into the miscellaneous section, you will see how to develop animated gridded surface data or Cartopy like something over there. So you can like go into this library's website and reference first. Since you guys are like at the very early stage of like learning these things, you need to go to their libraries and check for these examples. So after you learn this one, you will know how to develop the like modify the code accordingly. See, if you need a plot like this, the code is there. If you go inside, see, the entire code is there. But now the problem is you should be able to read this thing and understand where you should need to like modify. So you need to, first thing you need to know is where we are importing the data. If you know where we are importing the data, then you can like modify that simple line and then get the exact plot like this according to your need. And then if you are focusing on any area, you need to know how we can like zoom into or like clip into that specific area. So if you know that thing, then you can modify this code. And the other thing, you can use AI as well. But the thing is, you can use AI, but sometimes in the AI, we have something called hallucination. If you didn't feed like at the very first stage, if you ask something to like generate for the AI, they will generate. But the thing is, after generating that code, you paste it over there and you try to run the code, but it will give you an error. But if you didn't know how to like modify this error, what you are doing is you are typically taking a screenshot and uploading it into the AI again. Then they will think, okay, like this is the problem, and they will try to like solve the problem. But if you know what the actual issue is, then you can simply type the issue. Then they will modify it correctly. So you need to have simple knowledge on reading the code. I'm not saying like you need to know about 100% of coding knowledge or anything, but you need to have like simple knowledge on where to modify or what to ask. Because these days we have a lot of AI tools that we can go with, but now till now it's not that 100% like accurate. So you need to know small things related to coding, and then we can use CF plots and then GeoCAT visualization, GeoViews, and then these are the libraries typically we will use for the visualization. If you are plotting something, these are the libraries that we will use. And then these are the libraries that we will use for the meteorological related purposes. So if you go into the MetPy, you will see there are like lot of libraries in the MetPy. Sometimes you can use ACT. Let me open the MetPy library, because in the MetPy library we have like SQT diagrams and the wind diagrams. We can easily plot using MetPy library. So if you go in here, you see so wind chart and then SQT diagrams. So if you go into the download section, they have like lot of packages and even softwares. If you go over here, you will see they are the one who developed the Siphon and even HCDF and these libraries. And even they have data, and some codes are also should be there. So you can go there and like browse. So this thing, you don't need to like run multiple line of codes for this plotting if you know about MetPy library. Last time I see some guy was trying to develop it using like completely by himself. So if he know about MetPy, he don't need to do that thing again. So he simply needs to import this one, and over there are some coding structures that you can use. Then simply you can create a diagram like this. And then we also have some other libraries over here that I mentioned. These are the libraries that we will use for something. I see when I ask about the questionnaire, some guy mentioned about like radar as well, that he is focusing on radar. So if he is focusing on radar, he can use this PyArt package. So if you are working with the radar data, you can use this PyArt package for the visualization, especially the radar data and then even LiDAR. You can use it for both. Radar and LiDAR, you can use this PyArt, and then we have one library called, I forget the library. I will send it into the group when I remember it. And then we have some other additional libraries. So these are the things that we are going to discuss. So this is just the overview. So we will discuss about some libraries, not with all the libraries, because I cannot teach you all the libraries within like 10 days. So if I try to do that thing, you will never understand at least one library. So the main purpose is you need to understand some level of coding and some type of libraries that you can use. That's the main target of this program. This one is not working. Okay. So in addition to those libraries, we have these libraries as well. We are using for meteorological things. Like if you are using ECMWF data, you can use this one to calculate like thermal comfort indexes. Typically, if you know like how to calculate, if you don't know how to calculate the indexes, you can like simply import this one and like load the variables and call for that function, and it will give you output as the variables. So you don't need to do the calculation. You just need to call for that function and give the variables, and it will calculate the like every indexes and return you the final output. So that's why we are using these kind of libraries. And there are some guys who are doing oceanography. So if you are into the oceanography, you need to know about these kind of small libraries for your specific task. So then for the oceanography, they can use these libraries as well. And then most of the guys are into climate. So if you are calculating climate indexes like precipitation or temperature, there are some indexes that you need to calculate. Sometimes I see when they are asking like, can you correct this code? They send me the code. When I see the code, they are like doing the entire thing by themselves. So if they import this library, it has already pre-built library like functions. You just need to call for that function and give the variable names. You just need to load the data and give the variable names and call for those functions. At the end, they will give the output. So you don't need to like code the entire thing by yourself. So that's why I'm saying you need to know about these specific libraries. So if you know these specific libraries, you can simply call for this library, like import these libraries into your environment, and then you can simply code it using like any coding platform that you are like. So next thing is like data reduction. Sometimes we need to do data reduction like temporal or spatial. For spatial, you know, like if you need to downscale something, like the resolution, like rescaling or something, we need to know some libraries for like how to go from like lower resolution to higher resolution. You know, if we use like 30-meter resolution data for like wide area, the data size will be huge. So then we need to do this like what we call I forget the name. We need to convert it into a higher resolution data. So for that thing, we can use different libraries, and even sometimes we need to do the temporal conversions. You know, some data is there like per hourly data. We have hourly data. If you need to convert hourly data into like monthly or yearly, we can use these kind of libraries. So we don't need to like do it manually. So we can import one of these libraries and do that specific task. So for an example, if you go for climate simulation operations, like for this one, you can use this library for this one, like subsetting and then even spatial downscaling. So if you go into their website, they provide all the instruction like their API. Even most important thing is they have their own examples. Spatial subsetting, if you are subsetting like monthly or yearly, how you can do. So if you download like anomaly data related to this model, so you can import it and do subsetting like this. So this code is very simple, but if you go with typical Python code, it will be much more complex than this. So you guys can like go into these websites and start learning by yourself. After I like go through all the libraries, I will show you how to like read these things and everything. Right now I'm just showing you guys how to do. If you are going with the self-learning, you need to go through these things and check about the codes and everything. So all the information are there. So this one is like spatial downscaling. So how you can do the spatial downscaling. Even you see like this one is like typical diagram about the air temperature, how it's changing. So these libraries are there for this kind of task. And then we have spatial grids. So if we are going with the gridded data, we need to go with these libraries. And then the other thing is modeling. Some guys, I know some guys are doing modeling, not like the climate modeling. Some guys know WRF or something. For those kind of modeling data also, we can use this kind of libraries if we need to model something. And then even most important thing, everyone know about WRF. If they are doing climate related subject, they know what is WRF. So if you are into WRF, even in WRF, we have a Python module. So we can import this one and go with that thing for weather forecasting and related to research. So if you go with Ubuntu installation of WRF, it is around like 30 GB or so. But if you go with the Python version, is even less. So this is the cross-sectional diagrams we can design, and even we can predict the temperature and the cloud movement and everything if you know about WRF modeling. So that's why we are using these libraries for modeling. And then the essential Python packages. These packages I will discuss. So first thing is like we need to have an environment. So in the environment, we need to import all the libraries. And then over there, we will have like data manipulation libraries and even like data visualization libraries. But the very first thing is we need to have an environment. So into the environment, we will install all the libraries that we need. And then we will start coding. So we will typically discuss about NumPy because NumPy is the must known library that you guys need to know. Even Pandas and Matplotlib, these three are like must known libraries. But if you are working with like NetCDF data, and even you know some NASA formats are coming with HDF. So if you are working with NetCDF data, you need to import this library, NetCDF 4. But right now we have NetCDF 5 as well. And if you are working with HDF data, you need to import this library to read that file. And then, as I discussed last time, Cartopy is for spatial plotting. And then we have some other libraries like Xarray, Dask, Iris, MetPy. These are like much more advanced libraries for these things. These are the basic libraries. These are also like we can call as backbone of these MetPy libraries and other libraries. So this is also an advanced thing like you can read when I upload the slides. So if we come to the NumPy, what we are using NumPy for? This is the foundation for scientific computing. So everyone, if you are focusing on like AI or no matter what subject you are doing, you need to know about NumPy library. So this is a general thing. Sometimes you will not use Matplotlib or anything, but you will use NumPy and Pandas. No matter what, you will use NumPy and Pandas. Those two libraries is a must that you need to know. So we can use the NumPy with multidimensional data, what we call multidimension. Anyone know about multidimension? What we call multidimension? What is the multidimension like definition or the meaning? That means we have like latitude and longitude, and then we have T data. So in NetCDF files, we have multidimensional data. That means we can work with NetCDF files as well using NumPy. And then as you know, like if you are familiar with MATLAB, in MATLAB also you will use these libraries. And the next one is Pandas. Why we are using Panda? Panda we are using for the tabular data. If you need to get the average of a cell or like a column or something, column over row, if you know like Panda, is very easy. Within a single line, you can get the average of a column or a cell, like or a row, anything. So if you need to manipulate like tabular data, then you need to know about Panda. So that's why we are talking about Pandas as well. And then Matplotlib, as we say, this is the king of visualization. No matter what, any area, if you are going with visualization, you need to know about Matplotlib. That's why if you read any code, at the very top, we will import all the libraries. Typically, we are importing Matplotlib, NumPy, and Pandas. Those three are very common. In any code, you will see those three libraries are at the very top. So we need to know about these three libraries very well. And the next thing is like if you are focusing on climate related data, I don't think that the guys who are doing AI or computer science, they are using XCDF or HDF. But the guys who are focusing on climate and environment, they will use this one for definitely they will use this one. But in AI majors, if you're for like your supervisor or someone is related to like meteorology subjects, then you need to know about this data. Because someone I know, he was asking about me like, did you know about ECMWF data or something? Because his supervisor is asking him to learn about the data structure. He knows about AI and everything, but he don't know about the data structure. So first thing you need to know about the data structure before you like dig deep into the data. So he was asking about me. Sometimes if your supervisor is focusing on these subjects, they will ask you to go with these data sets as well. And then last, Cartopy. So this is the one if you are need to like focus on map. If you are focusing on mapping something in like any spatial data, so you need to know about Cartopy. This is the other library. So these libraries I will discuss in upcoming sessions. So if I have time, then I will go with other libraries as well. And then we came to the installation of Python. If you have the setup already with you, we can go with the installation. This is like very simple. For this one, we need to have package management tool. So in Anaconda, it's like pre-built. We have the Conda package management tool. So we can use Conda for installing any package. But if you are going with Python, you will typically use pip to install any library. But for if you are using Anaconda, you can use the Conda environment to manage your all the libraries. For the installation of the Python package, we can do either command line, and even if you are going with Anaconda, we have Anaconda Navigator, like graphical user interface over there. We can install the packages graphically as. So you just need to search for the package and then click install, it will install. But that's why I highlight here. You have like two methods. Either you can install the libraries using command line, or you can use Anaconda Navigator to install this package. So what is package management tool? Is like simply the as it mentioned, where we can manage all the libraries in our environment. First, we need to build the environment, and then we have to use package management tool to import or export or like delete or like do anything to the libraries. We will use the package management tool. So here we will use Anaconda. So there are other things like centralized repositories like GitHub or anything that we can use. And then the first thing. So that's why I ask you to download this one, Conda package management tool. Like for the Conda, we need to go with either Anaconda or Miniconda. Miniconda is the smaller version and Anaconda is the much higher version, because in Anaconda we have like pre-built libraries over there. Because if you go with the installation, you can see last time I show you Anaconda is like the setup is around 914 MB. But if you go with the typical Python installation, if I search for Python, if I go into the download, let me go to the download section directly. So if I go into the download section directly, you will see Python is very small, only like 3 MB or 4 MB. So what's the main difference in Anaconda to be like 914 MB and like Python to be around like 3 or 4 MB. So the main difference is Anaconda is coming with lot of libraries pre-built. That's why we are using Anaconda. Otherwise, if you're going with the Python, you need to like import other libraries as you need. Is taking some time. So here, if I download the latest version of Python, you can see it's around like 4 or 3 MB, not that much. It's very small. The size of the Python package is very small, but if you download Anaconda, is like very big. That's why that's the difference of between like typical Python and the Anaconda library. So you have to download the graphical installation package, and then over there in the Anaconda, they mention about the installation, how you can install it. So if you go into their installation website document, they mention how to do the installation. Over there, they mention how to like manage your environments as well. Because if you are going with Anaconda, you need to know about how to manage environment. So if you go into here, you will see installing Anaconda distribution. Over there, they have the installation instructions as well, how to follow. So in here, I will show you how to install, but sometimes you need to know, like if you didn't like forget the steps, here is the place, like you can go here and like search for the steps. Over there, they will show each and every single step that you need to follow. So if you have the setup, you can like double click on the setup and start installing this package. So it will take some time. First, we need to discuss about like how to deal with Anaconda, like how to import and how to export the environment. Because sometimes I know some guys, there are some guys who like studied here, and some guys are asking from them regarding the code. But as you know, libraries are keep updating. When they are upgrading the libraries, some of the like functions or anything that they like built in the previous stage, they modify. So if you know how to control your environment, like export the environment, then it will be much more advanced. Like, you know, if they send only the code without sending you the environment, you will try to import the latest libraries and you will try to run the code which was written like 5 or 3 years ago. Then it will give you some additional errors, like these packages were depreciated or something. So that's why I say it's better to go with a package manager like this, because with the code you can export the environment. If you have the environment and the code both like in your hand, after 3 or 5 years you can use the same thing, because you can import the same environment and run the code, because on that environment you load all the necessary like related libraries to that environment. So the website is not loading. Let me connect the hotspot. So if you guys have downloaded the setup, you can start installing the setup. Just load it and then so there's two versions of Python 3.7 and 2.7. When sometimes when you are focusing on some libraries, you will see in their like website they mention you need to have Python version 2.7, not 3.7. Sometimes you will like create your environment and everything in Python 3.7 and you will try to import that library. Last time, like one of the guy in our research team, he also focused on one package. It was built like 3 or 4 years ago, and he tried to load that thing in a Python like latest environment like 3.30, but that thing is built on 2.7. So after importing that library, it was giving like some errors that like out of this world. The main thing is you like the issue is it's supposed Python version 2.7, not 3.7. So after we like downgrade it to Python 2.7 and import all the packages, that like module worked without any issue. So once you download, you can double click on the setup and then you can click next, simply. Like if you have your setup like with you, you can like start installing this one. Then once your setup is finished, you will see, you can go into your search bar and type on Anaconda Navigator. Then you will see a window is loading. I think on my other screen is loading. After loading, I can show you. So try to install this one. Do I need to show the steps to install this one as well? So if you go into this site, it may shows how to do the installation. For the Windows installation, if you click here, you can install either using Anaconda website, downloading from here, and even you have an option to go with the command prompt, and then even PowerShell. You can copy this code. If you have wget, it will automatically download this one into the directory that where you are in, and then you can follow the step. But right now what we do is like we download the setup with the website. After downloading, then you have to do the agreement for the services, and then you have to install like just only for you or for all the users that your PC is used. If your PC is like in the lab, you know, if some other guys will also use your PC. So if you need to allow other users to use the Anaconda as well, then you can use like all users and click continue. So here it mentioned the installation steps as well. So if I need to show you guys, let me do this one. Let me see whether I have the setup code. Because this will take some time to install. So I can use someone else's laptop, no, who have the setup in their lap and like install I need one laptop who haven't installed the Anaconda. Did you install the Anaconda? So you install. So if anyone has a laptop who haven't installed Anaconda, I can use his laptop to show the steps how to install this one. Everyone has the Anaconda installed in their PC, then we can continue. We don't need to like bother with this install. Like if you have this one in your PC, if you have this application, then we don't need to install this. How many of you have this one in your PC? Just raise the hand. Just raise the hand so I can see. Okay, if how many of you haven't installed in this one? Because you need to have this one before going further. Everyone has this one? Okay, if everyone have this one, then we can discuss about this environment. Like this is one thing, and other thing, if you want type in the search like Anaconda, you will see two options are coming. Let me type Anaconda, and you will see Anaconda prompt as well. You will see Anaconda prompt and Anaconda Navigator. If you click on Anaconda prompt, you will see something like this. So these are two ways. Like this one is CLI. If computer science students, they know CLI mean what and command line interface and GUI mean what. So this one is the command line interface and this one is graphical user interface. So these both methods, like you can import your libraries and you can export your libraries, even you can like create environments, everything you can do using these both ways. But I will focus on the command line. not with the graphical user interface. I can show you the same exact procedure how you can do it in the like graphical user interface as well. But what's the time now? Is 6. Should I continue or we can start tomorrow discussing this one? So because we need to discuss about some things regarding Anaconda, like how to create an environment, how to export an environment. How many of you know how to create an environment over there? So everyone installed Anaconda mean like you use it before or this is the very first time? This is your first time. So you need to know about Anaconda Navigator before going here. Like you see, right now we are in home. So here you have all application and here what you have. So here I have the environment. So typically you can say like, just imagine you are focused like writing 3 research papers or like do 3 analysis. So for each analysis you can use separate environment. So the main thing is you don't need to touch this base, because if you messed up with the base environment, you need to reinstall the Anaconda environment. So you need to create environments for your task separately. It's like cloning the base environment and importing the rest of the libraries that you need. So here you will see environment section as well. If you go into the environments, you will see right now in my PC I have 1, 2, 3, 4, 5, like 4 environments, separate environments. But in your PC, most of you guys, if it is your first time, you will see only base. So first you need to know how to create an environment. So if I go with here, you can see in the base environment, these are the libraries that I have installed, like the libraries which were installed in the base library. So here you can search for some libraries. Sometimes I think Matplotlib, see the library that we discussed previously is pre-built, like already over there. And even NumPy should also be there. See, NumPy is also there. And even Pandas. That's why I say these all the libraries are pre-built when it comes with Anaconda. But if I search for some specific libraries like MetPy, I cannot find those libraries over here because I didn't import those libraries into the base environment. But if I go into my other environments like IMSA, these are my custom environments. So over there, I installed some additional libraries. So you need to know how to manage this environment. This is the main thing. Because I know you can use simple Python, and then if you know like VS Code or any other like text editor, you can do the coding from there. But this one is much more easy and it will advance. Like these years you will like learn some coding, and after you go back, sometimes you will be busy with the work, but later on not, you will need to do the coding part again. So if you created these environments and you exported the environment separately, you can like again import the same environment and do the coding again. So that's why you need to know about these things. Like how here you can see in the graphical interface, if you go to the environments, you will see all the environments like this. But now how we can see these environments in command prompt. So I say Anaconda prompt. In the Anaconda prompt, how we can see this environment. Right now you see my here typically in beforehand it mentioned base. So base is my default environment. So here you can see base or root. So right now I am in base. So how I can see these environments in my command line? So if you have a command for this, if you know like conda, as I mentioned, like package management tool, conda env space list. If you type list, then you can hit enter and you can see all the libraries. It will take some time, and you can see all the environments that which were installed in your PC. See, so it's giving me the directories as well. Where is this environment? So just imagine if I delete this folder, what will happen? For some case, my PC is showing like low space or something. If I go into this exact directory, like C and then users, under users is mentioning like .conda. Then here, if I go here and if I check for the properties in here, the size, if I need to check for the size, you can go and see the size. Typically, these environments is using huge amount of size, around like 10 GB or 17 GB. So accidentally, if you delete this one, that means your environment is also deleted. So you shouldn't delete this environment. You need to keep these things. During the installation, is asking where to install these environments as well. Over there, you have to configure where should need, like where is the location that you are going to install this environment. So if I go inside here, I have all the environments. See, test, MyENV and IMSA. These are the places where I install all the libraries. So I cannot delete these folders. I need to keep this one. If I need the environment, I need to keep these folders. So next thing is how to create the environment. So if I go back, you can give them the like A4 sheet or something. You have a paper, then you can give the paper. Okay. So let me go back with the presentation. So as you know, you have like two options as in here. You can see Anaconda, Navigator and Prompt. Navigator is the graphical user interface and Prompt is the command line. We will use command line for these things. So this is the basic things that you need to know. Installation of the packages. Next thing is how to install the packages. So step one is like we need to add conda-forge, because if you guys, this is the very first time of you will see like you only have, let me go into the Navigator and show you. If you go into the channels in here, you can like click on the base and go to the channels over there as well. Why is coming on this side of the screen? So if you click on channels, a window will be pop up like this, conda-forge and default. Let me take a screenshot and show you. You can see two sides, default and conda-forge. Most of you will see default. Like this, you will see one window like this. If you click on the channels, you will see one thing like this, and you will see conda-forge and default. Some of you guys, if it is your very first time, you will didn't see like conda-forge. You will only see default. How many of you guys have default over there? Only default, no? So the first thing you need to import conda-forge, because conda-forge is like you can search for conda-forge in the website. If you search, conda-forge have some additional third-party libraries. See, it's community-driven package. That means anyone can develop their own package and deploy it over there. So over here we have lot of libraries. So you need to import this conda-forge into your environment. So how you can import this conda-forge into your what we call to the package manager for the Anaconda. So for that thing you have to use this command in the conda prompt. If you go with the Anaconda prompt, in the Anaconda prompt you can type this command. Just type conda, then config -- add channels conda-forge. So this is how you can add channels. Channels mean like different, you can see like, you know, like typically we are using channels like to say like these are the ways that we can go around. So these are actual like the ways that you can go around with the packages. So now what you are doing is, if you click enter, you can click enter. But right now in my base environment also I have this one. So was there a conda-forge already installed in channel? So here it's giving that I have this one already in my channel. But for you, if it is very first time of you, like you will give a successful message or something. Just check for the spelling. Sometimes you have to check for the spellings. And the other thing, this is not CMD, command prompt. This is not command prompt or PowerShell. This is like Anaconda prompt. Like just type Windows and search for Anaconda. Then you will see, not Anaconda, just search for Conda. You will see, no, you can search for Anaconda. If you search for Anaconda, you will see two options, Anaconda prompt and Anaconda Navigator, as I mentioned last time. In the slides, I think I show it to you guys. So if you search over here as Anaconda, you will see Anaconda prompt. You have to click here. Click on Anaconda prompt. And then it will load this window. Over there, how to see all the environments that you have right now in your PC, you need to know this command. This is the very first thing. Conda env list. By typing this command, you can see all the environments which are currently installed in your PC. And the next thing, you can use like add channels like conda-forge channel, because in conda-forge we have like lot of additional libraries, so you need to go with conda-forge. So you can add conda-forge into your current environment. And then you can install. So just imagine in your current environment, if you need to install anything, if you know the package name, the command is conda space install, then space your package name. So here you can see in this example, if you need to install multiple libraries at once. So this is the first thing, conda install is very first thing. So that's the actual command. And then I need to install Xarray, Dask, NetCDF4, Cartopy, CMOcean, CMD line, province, these all the libraries over there. So I can simply type conda install space, all the libraries names separated by space. So it will automatically start downloading these all the libraries. If you need to have like working internet connection. And the other thing, some of these libraries I think is restricted in China, so you need to have a VPN. So if you have a VPN turned on, sometimes it is giving these issues when you try to import some libraries. So then you have to turn on the VPN and try it again. So the other thing is creating an environment. This is additional thing, like how to add the channel and how to install the package. But now the problem is how you can create an environment like this, because this is the basic. Before you go begin with the coding or anything, first you need to create your environment. This is just like your lab. So first you have to select your lab space, and then you have to import all the necessary items like libraries. First you have to create the environment, then you have to import all the libraries that you need, and then you can work on that inside that library. So just imagine if something happened on that environment, you can delete that environment without any issue, because you know it will not affect for other environments. If I am working with IMSA, like in this environment, and something happened, the environment was crashed, so I can delete only this environment. But the problem with this base is, if I like crash this base environment, then I have to reinstall Anaconda again. But if I create an environment, that environment is crashed, it's okay. But if I crash base environment, then it's a problem. So how we can create an environment? So create an environment, you can type conda create dash n and then your environment name. So this is a single command where you are importing all the things. So here if you see conda create dash n mean create new environment, and then this is your environment name. Then after spaces you are mentioning in this environment, this is single command, not like two commands. After creating the environment, install these libraries over there in this environment. So install Jupyter, Xarray, Dask, NetCDF, Cartopy, and these libraries inside that environment. So it will automatically create the environment for you, and then even install all the libraries for you as well within a single command. Or you can divide this one. You can create the environment and then you can install the libraries. It's up to you. And then you have to activate that environment before you use that environment. Here you can see in my command right now with the star mark is showing base, because right now the activated environment is base. So to change the environment, you can see conda activate, then your environment name. So here if I type conda activate, and then IMSA you can see now is saying like C double lane. We type C double lane. So if I delete one and hit enter, you will see in the front something is changed. It's changed from base to IMSA. That means right now I am working in my that environment, IMSA environment. So if I hit the same command again, conda env list, you will see that star is shift from base to IMSA. See, now that star is shift to IMSA. That means I am inside my IMSA environment. So over there I can start coding. So now you guys, what you guys can do is you can create an environment. Try to create an environment. So what's the command to create an environment? Now you know the command to is like create the environment. What's the command? You don't need to type these all the things. Conda create dash, then like you can type your environment name. Just type IMSA training or something. I will create. I also follow up with you guys. So I will create new environment as like how you can create new environment. Conda create dash n for new, and then IMSA underscore I will type training. So this is to create the environment. So if I hit enter, you will see it will take some time to create the environment. That means it's cloning your base directory and creating new environment. See, it will say take some time. At the end, it will say successfully created the environment. You can try to follow up the same thing. Right now, I am showing you how to create the environment, and then you need to know how to back up the environment as. So you guys can type this one and like try to run the command. Sometimes it will ask yes or no. Just type yes. You can type Y and hit enter. Yeah, it will take some time. So after it is finished, it will say every transaction is done, and at the end it will say activate this environment. You have to use the following command. Not recognize again. Add channels. That command is correct. Add channels is separated by add or something. So you have to give a separate like between dash dash add then channels, not together. So once it's done, you can now type the same environment. How you can see the environments? All the environments you install in your PC. You can type that command conda env list and hit enter. So you will see all the environments installed in your PC. So now you should see this IMSA training and base both. So now how you can activate this environment? You need to know how to activate this environment. Just activate this environment. You guys know the command. Even after you create the environment, it shows the steps of how to like activate the environment and how to deactivate the environment. Just activate that environment. How? What's the command? You have to type A. Just type A. Not yes. Why is giving this kind of issue? It's okay. So now After you create the environment, you have to type yes. Now it's asking proceed. You have to type Y. And how you can activate that environment? Conda activate, then the environment name. Simple command. Just create the environment. What's the name? Just type that thing. Conda create, then your environment name. For this one, you can give like IMSA training or something. And hit enter. What? Yeah, it should be like separate. When you add in channel, it should be like separate. Add channels and then space channel name. Yeah. Then you have to give a space and then conda-forge. Conda-forge. You have to type dash n in here. Create. Since you are creating new environment, you have to create dash n insert. Yeah, you have to type a space in here, dash n. Should be conda. Kona. Type kona. Conda. You type CONA. So how you can activate that environment? Conda activate IMSA dash training. So now that environment is activated, I can see. So now next thing, how I can export this environment. So next command you need to know is how to export this environment. So here, if you go into the Conda, last time this website takes some time to load. So if you go into the like managing environment section, it shows how to create an environment. The command conda create dash dash, then your environment name. That's the command that we use. Either you can type dash dash name or simply dash n, then your environment, and then it will ask you to proceed, like type yes and continue with the agreement, and then even you can type this one. This is the other command. Just imagine you need to create this conda environment specifically focusing on one Python like package, Python version 3.9. Right now I didn't specify the Python version. I just say conda create this environment. So now what will happen? It will create the latest version of Python environment, not the older version or something. That means like latest I think 3.14 or 3.30. So it will create that environment using Python 3.30. But if you need a specific environment like Python 3.7 or 2.7, you can use this command env then Python dash the version number of Python, and then this is how to install, and then some other things like specify library. Then last time I mentioned how you can install the libraries alongside with creating the environment. So you can type environment name, then the library name as. So you can specify these things. Even for SciPy, that means scientific Python package, over there they have also some version. So if you need to install the like specific version of that package, you can mention SciPy like equals then the exact package number, the version of that package. So I will not discuss with these things now. So these are some additional like commands that you can use. I just use the basic command that you can use. And then the next important thing is how to create an environment. That means now I am talking you how to back up your environment. This is the other thing. So we didn't install any like libraries or anything over there. Now how we can back up our environment. That's what I say. If you write the code right now, you can export the code using IPy or .py format. But the thing is, for that thing you use specific libraries. So how you can like export those specific libraries? So you need to export this one, like your environment, in .yml format. So how you can export this? So for that command, if I go down, where is the command? The create for EAPS. So this is the command where you can export your environment. So for this thing, you need to specifically focus on where you are right now. So I'm not going to discuss right now where like you are in C users your like folder name. But if I type this command like to export this environment, I can type conda-env export, then less than sign, then the environment name. I can give an environment name and then click. I will copy this one and paste it over here directly. So conda-env export. You have to type this command. Just type this command. Now what you are going to do is like you are going to export this IMSA training environment as a .yml file. So you can type conda-env export, then less than sign environment. For here you can change. You don't need to type environment. Okay. Here you can change to whatever thing that you like. You can change. This is like your environment name. So here I can type like IMSA dash training env. I type like as this. So now I am exporting this environment to this YML file. If I click enter, nothing will happen, nothing will appear. But at the end, if you go into this directory, you can go into C users, this username, and over there you will see this YML file. Try to go into that directory using the file manager and open that place. So if I go into this PC and then I was in users and Dinesh. So here I have like lot of files. If I scroll down, you will see I have, where is it? So I have this IMSA training env.yml file. You should have this file over there in your directory. You can just see in here, you can see in the command prompt is showing the directory. Right now you are in C users, then your username. So if you go into this directory using your file browser, you will see this .yml file. Just double click this file and open. If you have a text editor, it will open. Right now I have VS Code installed in my PC, so it will open up in the VS Code. So if you have a text editor or something, you can open this one in a text editor. So if you import this one, right now you will see the channels that you loaded. You will see the channels, and here you should be able to see all of your libraries. But why we are not seeing any libraries? Just like let me import another environment that I have created. So if I open this one, so here you will see right now this one is another library that I dependencies, that means the libraries. So you will see libraries and there are specific versions as well. But right now in IMSA environment, why you are not seeing anything? Why? We didn't install any libraries. So now let's try to install one library. So how we can install? Just imagine Panda. What's the command? You can just imagine, or you can search in the web. So you can simply type how to install Panda. So there will be like two ways, either pip or Anaconda. So I know the command, it should be like conda install Panda. So let me click here. Or you can like go to the Panda directory, and over there also they will mention. See, either I can install using pip. If you are familiar with Ubuntu, you can using pip and pip3 also there. Now we are using conda. So from the conda, how we can install? Conda install pandas. So you can type this command. That means if you need to install any library, the basic command is conda install and then your package name. So if you need to install pandas, you can go into your Anaconda prompt. Now my activate environment is IMSA training. So I will type conda install pandas and click enter. So now it will download. For this one to work, you need to have an active internet connection in your PC. Just check whether you are connected to internet or not. Because now it's going to access internet and download all the necessary packages to run Panda from the internet. This is the command conda install, then your package like library name. First double check whether you activated your channel or not, because if you are in base and you try to install this one, what will happen? It will install pandas in your base directory, not in your current directory that we created. First you have to double check whether you activated this channel or not. As I know, we all activated this channel, so it will install that library into this environment. So it will take some time and you need to have internet. So if you have a good internet connection, it should like download. Yeah, there you will see like on the right hand side we have like all the necessary dependencies libraries. These are like additional libraries that we need to have to run pandas in the PC. Yeah, it will take some time, and then you also can see the same screen like this. You need to have like active internet connection. Yeah, now you have to install that library using conda install, then library name, and hit enter. See, now it start downloading all the necessary libraries. You can see Python, Pandas version 2.3.1, and then NumPy 2.3.1. So other additional libraries which are needed to run pandas, it will start downloading. So that's why I say you need to have like active connection for this. Yeah, now you need to install one like simple package. Conda install, then pandas. So now you, if it is finished, now you can export that library and try to open that YML file. Then you will see instead of like channel names and the rest, you will see some libraries will be also there. Now how next thing is how we can install this environment using a YML file. Now we need to know, right now we back up the environment. Next thing, for some case, you like change your laptop or you need to install the same environment on your desktop as well. So you can clone the same environment using that YML file. So for the next like sessions of the channel, like our training, I will give you the channel environment I created. So you need to import that environment, because the like libraries I used over there. Yeah, for this thing to work, before you run this command, you need to like connect it into the internet. Okay. If you didn't connect into your internet, it will not work, because this thing is like browsing the internet and installing it directly in your PC. So you need to have like active internet connection. Install pandas. You have to type this. So after this thing finish, you can export that environment and check the YML file. What? So you have to type conda export. Conda, then you are going to export the environment, no? Conda, then env, then export, and then greater than and your environment name. For this one, you can give any environment name. I will simply give IMSA. IMSA dot YML and then hit enter. So why is giving issue? Right now you are in like base.
No, I activated IMSA. This one down.
You activated. What's the issue? Invalid choice. You have to go all simple. Just try to type all these things in simple. You type in caps, no?
No.
Yeah, type conda env export, then type command. Last time also you try to like export using the caps, no? Export and then less than and then your environment name dot yml dot simple yml, type simple yml, then hit enter. Now you should see this file in this place. Go to see users windows, then you will see this IMSA yml. So if this thing is finished, you can try to type the same command and check. So I will export this one env2. So I need to have a comparison, no? So I will export this one as env2.yml. So now if I open that file in here, env2, so if I click here and open that one, now I have some libraries. So now just imagine if you need to send your code, the code that you develop to your friend or someone, you have to send your code along with your environment. Then he can like run the same exact code. Otherwise you send your like code, only the code, or like .py file or IPy, like for Jupyter notebook format is IPynb or something. If you send only that thing, it will not work on his PC. But if you send this YML file along with the code, he can simply export that environment, like import that environment into his PC and then run that code. So it will run without any issue. So now you need to know how you can create an environment using this YML file. So how I can create this environment using this file? Now you see the name is IMSA training. So if I type the command to like import this environment using this YML file, it will not work because right now I have an environment with the same name. So now, okay, let me delete. How we can delete an environment? Next thing is you need to know about how to delete an environment. You did the task, you export the environment. So to save the space in your PC, you don't need to keep that environment because you have already exported that file, the environment file. Whenever you need that environment, you can import that environment and like load it again. So if you need to delete, how you can delete? So that command is also here. You can simply go into the website. That's why this is like self-learning thing, no? So where is that conda directory? So I can simply search for this. So it will give like first I need to deactivate the environment and then remove dash dash name, environment name dash all. So this is the command to remove the environment. So where we have to rename is this one. So you have to rename this one with your environment. So how I can do? Let me copy the command. You can try to delete. Before deleting, what we have to do? Right now, can we delete this environment? Can we delete this environment? Because right now we are inside that environment. So first we have to deactivate. How we can deactivate? What's the issue? It should be like deactivate, not conda. Let me go there and see. So at the beginning is so like conda deactivate. You don't need to type the environment name, just type conda deactivate, it will automatically deactivate. You don't need to specify the environment. So right now you can see, you go back into the base. Since you have like two environments, you will go into the base. Right now, before I activate this environment, I was in IMSA. So it switched back into the IMSA environment. Now I can delete that environment. So I will type this one and then my environment name. What's my environment name? IMSA underscore training. And then with all command, if I type now, it will delete that environment. So it will ask me to confirm. If I confirm, it will delete all the packages and everything in that environment. And then you can view all the like environments using like conda env list to check whether this environment still exists or not. Because these are the basic things you need to know, like how to view your environment, how to create the environment, how to install the libraries, how to backup it. So those are the basic things that you need to know. So it will take some time to delete. After deleting the environment, you can type conda env list and see whether double check whether this environment is still over there or not. You are still installing it or like removing the environment? You are installing it now? Yeah, it will take some time because the PC is slow. Yeah. You try to export this one, like see, now you are in base and you are trying to export that environment into this name. So first thing you have to activate your like previous environment. So what's the command to view the environment? Conda env list. So you have to type this and see all the environment. That's why I say then you know this is the environment that you need to activate. So how you can activate that environment? Conda, then activate, then space your environment name. Type this one. Either you can copy and paste or you can type. So you can copy. See, now you can export this environment. Right now what we are doing is like after exporting, you can delete that environment. Right now what we are doing is deleting the environment. So yeah, just try to export this one. You can export this like environment after installing the package. You can export this environment into env2 because we will use this one to reinstall that same environment using the YML file. So now you have to deactivate and now you have to type that command to remove. Conda, what was the command I typed? I forgot. Conda env remove. Let me show the command. You have to type that thing with the IMSA training. Now let me show you. So After you like remove this one, let me see whether it's removed or not. env list. So it's still there because I forget to like type X, so it automatically exit. So I need to type the same command again. That means you have to type this one, conda remove dash dash name. You guys also can type the same command. This is the command name. Just type this one, conda remove dash dash, then the environment name, then double dash remove all. So if you didn't specify this one dash dash all, it will only remove the environment, not the libraries. So libraries will be over there, so it will delink, only like delinking from the env list. So the folder will be there, but it will not appear in the environment list. But if you type double dash dash like dash dash all, that means even delete the folder as well. So it will delete that folder as well. So now you have to hit this command, and then it will take some time to remove all the libraries from there. You have to click yes, then it will delete. So now if I type conda env list, that library, like that environment should be not appear over there. See, that environment is deleted. Now next command is how to import that environment using that YML file. So now the thing is, my YML file is in here. Just imagine I send you this YML file from WeChat. Okay, you saved this one instead of this directory, you saved this one in D. So if you let me save this one inside here as well, IMSA training, there's one thing over there, no? Training 24. Okay, I will save this file in here. Okay, now my YML file is here. So I need to create an environment using this YML file. So how I can do it? So first thing is you need to go into that specific location. So my file is now in D, another folder. You also can like copy this file into somewhere else and try to change. So how we can change into D, this folder? So how we can do? If you know about, if you are familiar with command line, cd, that means change directory, or simply first I will change into the local disk D. So D, then double dot. So it will change into the D. Instead of C, now I am in D, local disk D. So now I know my folder, so I will type cd change directory, IMSA, what folder I put, IMSA training 24, I think. Yeah, IMSA training, not IMSA, training 24. So I can go into this folder name using training 24. So like this, you can go into that specific directory, and if you type dir, you will see that file. So in this directory, I have this YML file. First thing, when you are creating a environment using the YML file, first you have to go into that directory before you start creating the library. Otherwise, you have to specify the entire path, or you can go into that directory. Now, what's the command for this one? So for this thing also, like you can search. Actually, I know the command, but to show you like how you can like improve yourself. So you have to search. That's why we have like even in AI you can ask. Otherwise, you can simply search. So like conda create environment using .yml file. So see, it's simply showing me the step. Conda env create dash f, that means from file, then my environment name. This is the simple step. So conda create env dash f, then my file name. So I will copy this one and go over there and paste. But right now, what is the name of my environment? From here I can see IMSA training env2. So I can type conda env create IMSA training, not there are env2 YML. You can like simply type the first two letters and hit tab. So it will automatically search through, like loop through all the things over there. You don't need to type the environment, like entire thing. First, you need to go into that directory where this YML file is and then type this command. You have to type this command. But before that, you need to know that you have to go into that specific directory where your file is, and then you have to type the command. If that YML file is not in that directory, this command will not run. It will give you an error. So this will be the last command that we are talking today. So tomorrow we can go with like installing like the libraries and then going with NumPy. First I will talk about NumPy library because that's the other thing that you guys need to know. And we will have some exercises as well. So you can hit enter after typing this command. So it will start creating the same environment using this YML file. So next day I will send you an environment which I created. So you need to know these commands. I will never repeat these commands. So you need to import this YML file and create the environment before we start the training. See, now is reading all the packages and even the environment name, and it will start creating the environment. After that thing, you can see by typing conda-env list, that environment will be appeared over there with the same environment name. So last time I say to remove this one, you need to deactivate the current environment because you are trying to delete this environment. Before delete this environment, you need to deactivate the environment. So you have to type conda deactivate. You type D at the beginning, so you need to conda deactivate. And now you have to delete. Now it will delete. Now it is asking yes, no. You have to type Y and hit enter. You have to agree that you are allowed to delete it.
To create that directory, I created the folder this time. Yeah, I don't know how to do it.
Oh, now the problem is like you have to go into that location. So you have to go into this, like inside here you have that file, no?
No, the file is still.
So you have to copy that file. Just copy that file over there, that environment file, and put it over there. Then you have to change into that directory and install it from there. This is the name that you put over there.
Yeah, but I don't think it's this one because this is the one first created, but I created the one with what?
The other file as well. I think you didn't export that thing, no? You didn't export at that one. You only export the first file. Ah, it's okay.
Okay.
This is just to show you how to like import this one from there. So why I am showing this step is like you will see sometimes the guys who are in coding, they know we have something called GitHub. In GitHub we have all the things. Just let me show you. A-T-R-A-C-K. So see, this is one like package over there in the GitHub. So over there, they have the command, but with the command, like you see, you have the script file. So you can run this script. So the code is over there, even the data is also there. They provide notebook file and even the scripts. Along with that thing, you will see one thing. See the file that we discussed, envpy3yma. To run this code, simply you can download this entire thing from here. Just download it as a zip. So you can download all the scripts and everything. You can download. But to run this command, like run this like atmospheric tracking code, you need to have that exact libraries that they imported to develop this code. So that's why with the code, like here, the Jupyter notebooks, if you double click in here in the notebooks, you will see input data, output data with along with the code that they have developed. So this is the Jupyter notebook file. So if I double click, you will see the code that they have developed. But to run this code, I need to have that exact environment. Otherwise, it will crash because this one was developed 2 years ago. From here, you can see they developed this one 2 years ago. So these packages sometimes may be depreciated in the later versions. But luckily, they provide us this YML file. So what we can do, see, the same thing is there, package name and even the channel names are also there and even dependencies. So right now the NumPy version is not 1.20 point something. So if you search for NumPy, latest version, it should be like 2.2.0. So what will happen? Conda install NumPy, it will install the latest version 2.2.0. And I try to run this command. Will it work? I try to this like notebook, this notebook. Will it work in my PC? No, because why? In their environment, they are using NumPy version 1.20. So luckily they provide the env file. So what we can do, we can download this one and import the environment and then we can run the code. That's why I show you these steps. So after 3 or 4 years, you will forget your code. But if you have both code and both environment, you don't need to worry. You can import the environment and then you can run the code inside that environment. It will work without any issues after 2 or 5 years. So right now we discuss only regarding like backupping your environment and creating the same environment. So now you can see that environment is like already created using that env file. So you can type conda env list and you will see that environment is over there. So next thing is Jupyter Lab. So I will activate this environment again using this command. Like you can copy, if you are like so lazy, you can copy that same exact command and paste it over here. So next thing is we are going to like run this one in either, we can use like either Spider or Jupyter Notebook. We are going to use Jupyter Lab because like it's the easiest way. How many of you are familiar with Spider? You familiar with Spider? Only you. What about the rest? You are also familiar with Spider. What about the rest? Only two. Jupyter Notebook. How many of you have used Jupyter Notebook? So most of the guys are familiar with Jupyter Notebooks. But you didn't use Jupyter Lab. You only use Jupyter Notebook, no? But Jupyter Lab is much more advanced. Because I will show you guys, because in Jupyter Lab, we have these all the things. So if we discuss about the project Jupyter, they have Jupyter Server, Jupyter Widget, Jupyter Notebook. So you are only talking about this one. If you install Jupyter Lab. Jupyter Lab comes with like this kind of environment. In Jupyter like notebook, you will only see the notebook file. You cannot see your like folder directories and your files. You cannot even browse your files. You will only see your notebook file. But in Jupyter Lab, even you can debug the code. You can see what are the variables that you have imported and their data type and everything. So we will go with Jupyter Lab. So to install Jupyter Lab, you can type in here, just activate your environment and install Jupyter Lab over here, conda install Jupyter Lab. You can type this. So it will install Jupyter Lab in your that environment. So now we are installing Jupyter Lab in our environment. So this is the platform that we are going to start our coding. Till now we didn't start like coding. We just discuss about how to create the environment, how to export the environment, and how to create the environment using the file. Because this is the very basic. Sometimes you will like do your entire master's research or something over there in the base directory, and at the end the directory crash. So what will happen? So you have to start doing it from the scratch. Even you forget like which kind of like versions that you have installed, the library versions. But when you try to run the code using the latest versions, it will give you error. To solve these errors, then you have to retype the code again. So it's better to import the libraries. Whenever you import a library, just back up that environment and create save it in a safe place. So it will take some time to install. So this is the way how you can install like libraries. Now you know how to create an environment. What's the command to create an environment? Conda create -n, then environment name. If you need a specific Python version, conda create, then -n, then environment name dash Python equal the Python version. And then how to install? Conda install, then the environment name. So here it will take some time to like download the same thing like this, like previously. So after installing this, we will finish for today, and we can discuss from tomorrow onward regarding the Jupyter Lab and how to code it. Because in the Jupyter Lab, you can do like markdown. That means you can type whatever the thing that you are going to do in the code. Like in the text, you can specifically type. It's just like a notebook. You can type, okay, in this section, I'm going to do this, and then you can code, and then you can run the code. Everything you can like do in over there. But in like Spider, you have to do it in the comment format. Yeah.
Yes.
Yeah, I will send the environment tomorrow. Now you have to go into that directory. It's in D trainings, no? Training 24. Now from here you have to change into that directory. You have to move into that directory. Just go into the command prompt and how you can change the directory. So you have to go into the D first and enter. Now you are in D and now CD your file name. Just use like simple, don't use capital. This is still capital. So after installing this one, to load the Jupyter notebook, Jupyter lab, you can type Jupyter dash then lab. So then it will load. Should be JU. So it will start Jupyter server and then it will load through your browser. From tomorrow onwards we will discuss, because all the coding will be conducted over there in the Jupyter lab. So now it will load in your browser. So this is the interface of Jupyter notebook. Over there you can create the notebooks, and then even we have the console, and we have some other additional things over there. So we will discuss about these things tomorrow. So you have the file manager, and even if you turn on the debugging, in here you have a bug icon. So this is to turn on the debugging. Whenever you run a code, you can see what are the variables that you have loaded, everything you can see. So from here onwards we will go with Jupyter lab. So for like when you are coming tomorrow, just install the Jupyter lab. Even I will send you the YML file that we are going to use tomorrow. So try to import that YML file and create the environment and come tomorrow. So we will discuss about Jupyter lab tomorrow, and then if we have the time, we will start discussing with the NumPy.